In Lecture 5, I mentioned that there are various fundamental forces of nature which fall within 4 categories: gravitational force, electromagnetic force, strong force, which holds the nucleus of an atom together, and weak force, which only plays a role on the atomic and subatomic scale. Actually, I think I had you read about this. So where does tension force fit in? Normal force, friction. It turns out that all of those are electromagnetic, oddly enough, and in fact every force we experience as humans is also electromagnetic, except gravity. Gravity is unique. The study of physics and science can largely be traced back to a fascination with the celestial bodies in the sky. Gravitation was the first of the 4 fundamental forces to be studied extensively, and along with his 3 laws of motion, Newton also published a 4th law of gravitation. And it states, every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of the masses of the particles and inversely proportional to the square of the distance between them. And in equation form, this reads, Fg is equal to the gravitational constant, capital G, and is the mass of one is the mass of the other divided by the distance between them squared. And this G has a value. It's just a number with certain units. It's equal to 6.67 or 6.6 repeating. Well, actually not. Times 10 to the negative 11. The units are newtons times meters squared per kilograms squared. Notice that the law of gravitation is consistent with Newton's 3rd law. Each body feels an equal magnitude of force regardless of its mass relative to the other. When you jump up and fall back down to the earth, you are attracting the earth towards you with the same force that it is attracting you to it. The earth moves to meet you. It doesn't stay stationary. Of course, the earth's mass is about 10 to the 23rd times greater than yours, and so its acceleration, F equals ma, is 10 to the negative 23rd as great as yours. Spherically symmetric bodies can be treated as point masses, which is supremely convenient because most celestial bodies are spherical. Moons, planets, and stars all tend to be spherical since all the particles in a body are gravitationally attracted to each other. And so the minimum energy distribution is therefore the most compact geometry, the sphere. The universe is lazy is a nice concept to remember throughout much of physics. A common question is, what gravitational force would you feel if you drilled a hole through the center of the Earth and traveled through it? Interestingly, the closer you get to the center of the Earth, the smaller the force of gravity you would feel, because you're getting closer to a uniform mass distribution around you. At the exact center, it's attracting you equally in all directions, and so the net gravitational force on you would be 0. Gravitational forces are often talked about as comparatively weak to electromagnetic forces, and indeed they are. But I'll add something different to the conversation. I like to think of each category of force as being dominant for a certain scale. On the subatomic scale, we have strong and weak forces that dominate, but there are also electromagnetic and even gravitational forces present, however weak they are. On the human scale, electromagnetic forces dominate. Electromagnetic attraction and repulsion of atoms that make up material objects are the reason for every human scale interaction. Then, on the planetary, stellar, galactical, and beyond scale, gravitational forces dominate. It's common to hear people say how small and insignificant the vastness of the universe makes them feel, but I find it rather extraordinary that us humans are large enough to notice gravity. I mean, who knows how far the scale of things that exist in our universe extends on either side of us, from smaller than us to larger than us. And isn't it just wonderful that you get to experience the force that dominates the largest end of the scale that we know of? Jump up and down a few times today and think about this. It'll make you feel as large as a planet. You are significant even on the celestial scale. I think that's just extraordinary.